Good afternoon, everyone. Good morning to those of you that it is still the morning. My name is Lauren Rathmel. I'm the conference producer for the Recycling Today Media Group. We're going to get started here in just a minute, just letting everybody filter in here. So thank you so much for attending this BHS webinar, AI and the Future of Recycling Facilities. Just wanted to make a couple notes before we get started. We'll do Q&A at the end. There is a Q&A button at the bottom of your Zoom screen. Feel free to put your questions in. We will try to get to as many as we can with the time that we do have. Any registered attendee today, you will get access to a recording of this webinar within 7 to 10 business days. So if you missed something, want to go back, definitely we'll make that available to you. With that, I'd like to introduce our speaker today. We have Thomas Brooks. He is the Chief Technology Officer at BHS. As the Chief Technology Officer, he leads all research and development activities for the BHS family, and he's been instrumental in developing the Max AI line of products in addition to other emerging technologies. And it looks like we've got his presentation up and ready to go. So with that, I'm going to toss it off to Thomas and go ahead and get started. Thanks, Thomas.
Okay, great, Lauren. Thanks for that introduction. Yeah, perfect. We're going to go through, I guess, good morning, good afternoon. I think we got a full list of attendees from all over the world, so welcome. We're going to get into a couple of things that are really near and dear to my heart, which is technology application, what impacts those have to the business. As part of that, as we talk about material recycling facilities, I wanted to give kind of a brief introduction around BHS, kind of who we are, what we do. BHS is really a company that's focused around material processing. The center and kind of heart of our business is around solid waste processing. And we've progressively grown a business out that touches, all the different aspects of that. And really, it's a collection of a multitude of companies that bring forward not only innovative technologies, but also, kind of a vast experience of how to integrate those technologies. And especially as we start to talk about, what's the future of waste and recycling facilities? How do we integrate this new technology around AI, machine vision, machine learning, all of these new pieces? It's really important to have a firm grasp of kind of the integration that goes into those. And so we've really kind of assembled a group of companies there to really give us a broad reach and allow us to provide, very real world services, and as well as gain some real world experience. And we're constantly learning and growing the new ways to do that. With any technology, especially as we're talking about how we develop that and how we deploy that in the future, which is really kind of the focus of this discussion, we really want to come back to the core of what are we trying to do? What are we trying to accomplish here? And in order to do that, especially around material recycling and waste handling, we really want to look at much of the commercial impacts that we're seeing in the space that are really becoming barriers in many ways to kind of widespread recovery. I know we've all seen the images of, the great plastic patch that sits in the Pacific. We've seen some of the Asian wash up. We've seen some of the climate change concerns that exist around the world. And we know that while it's not the core contributor, a major contributor to that is solid waste and how that's being handled. And how do we drive more of that to be impactful in the space that we live in, day out? So really recognizing what those issues are and how those are driving problems for operators, which in turn drive large-term awareness, is a major piece. So, really none of these challenges, anybody that's been in the industry for any amount of time, none of these challenges are really new, but a lot of them are becoming much worse, especially as we talk about staffing issues that we've had. As we've come out of COVID, we still live in kind of a COVID level world. How do we reconcile that? How do we work through people placement? How do we deal with variability in the waste stream, which is going to be a big piece as we start to go forward? We're going to talk about data. We're going to talk about more specifically actionable information that comes out of that. So as BHS NRT identified the need for how do we grow and change the space, we really looked at those core issues, and we then try to define technical objectives, which are going to carry us through that. And much of that has to do with the ability to recognize material, the ability to make decisions on that recognition, and carry that forward into something very actionable, right? So in what we're focused on today, especially around AI, we use AI in its core capacity to really identify things that don't necessarily sit within another core technology, right? So if you talk about NIR, you talk about RGB, you talk about even X-ray, mid-IR, all of those different spectral information, there's some deficiencies there around the core algorithms that support that, right? So as we talk about AI, we realize that AI now bridges that gap and allows us to implement those other technologies. On top of that, having that information now really drives to the core of what we're trying to do, which is industrialization, right? How do we now drive a scenario where we have the ability to commercialize recycling, where we can drive initiatives around that, and where we can further raise society awareness around what's there, right? And we do that in a couple of different ways that we'll talk about in more of the detail, but really trying to drive kind of this bottom line performance around how we enhance that. So as we go through, we talked about the issue, we're talking about the solutions, and then at the end of this discussion, just before the question and answer, we're going to talk about some very specific applications that BHS has implemented and been very successful at, and we'll talk about some of the details of that. Again, sitting at the core, when we endeavored into the space of AI, artificial intelligence, late 2015, early 16, the real focus was around how do we replicate detection, okay? If you look at the reason that we have humans present in any system, that's really around their ability to recognize, their ability to facilitate object movement. If we focus on that first piece, which is recognition, that material classification, characterization aspect is just critically important to how we now integrate AI into the systems, and furthermore, drive ourselves to this industrial, what I'll call paramount or mountain that we're trying to get to, which is really around the core automation, the autonomous facility that we talk about so much, in that a facility has the ability to make decisions on data that comes in. Well, really the first fundamental piece of that is I've got to take the material stream that's presented to me and be able to use that to convert that to ones and zeros to then make a decision. At that point, computational hardware is extremely effective. One of the things that computers do reasonably well is they're able to make many decisions on multiple pieces of information to drive decisions. And so what we're doing now is taking AI, creating that classification information, and that has a bevy of forward movements that we can apply that into. In this case, you're getting a graphical sense of where we've progressed as far as AI goes. Really what we're driving to is in current space, we talk about pieces when we talk about material characterization. However, we're driving to a place where we need to understand the mass. We need to understand what goes into that. And we're really starting to develop our technology around being able to offer that and leverage that in a very real world way, so that when we talk about information, it's really based on data, but the data is not really the key driver there. Anybody can flood you with ones and zeros or charts until you're blue in the face. Really, our core driver behind AI and its application is the collection of the data, but then turning that into actionable information, which is where the value is added, especially as we start talking about facility operation and the utilization of these nuanced technologies to really drive business decisions, right? As we talk about more large scale trading efforts even that go into material. So BHS has really done this in a couple of ways. So as we talk about AI, we talk about systems that are in place, we really are focused on three core areas that we're deploying that in today. The first being our real-time material characterization. We have a biz product we offer for that. And that really goes into kind of the heart of everything we do. And that's basically the ability to recognize materials as they're coming through the system. We're not going to do a primer on AI. If you're looking for something along those, there's plenty of other videos that'll do that. Or if you have questions around that, we're happy to get into that. But that's really not the point of this discussion. But in our material characterization system, it's literally taking in the variability of the waste stream and applying that in a very real way, so that we now understand what comes through the system. Right? In many cases, we weren't able to collect that information before. If you look at the dollars spent around the world in the waste stream today at doing just core material characterizations, it ranges in the order of magnitude of millions of dollars that are spent annually from a variety of different companies, basically just trying to understand what's in my waste stream. We're not even talking about the processing. We're not talking about anything else, just that understanding. So as we looked at products, we said, okay, look, the material characterization's got to be paramount. We've been doing that since early 17 publicly and been developing that much prior to that. We also tie that into our system automation. And then as a build out, we typically talk about the deployment of Max in this see, think, act functionality. And so really what this is depicting is our ability to act in a number of different ways. We can do that with system automation and bringing that information back. We can do that in robotic sorting. We can also do that in optical integration. For us, if we talk about the robotic sorting space, we've really bridged out from that. We originally started off with simple Delta bot, one unit sitting in a space. We've since expanded that out, understanding the need for really the labor replacement need. If you're talking about a facility that needs that quality control aspect to it, you've got to either have labor or you've got to have some replacement for that. And for us, the robotic aspects of that is just paramount, because not only does it provide that sorting action that sits over top of that, it also providing the material characterization. So every one of our Max AI products provides that data back. We're going to talk in a minute about our TIP, our Total Intelligence platform, that we've utilized that facilitates all the different functionality. But as we talk about our Max AI product line, it's really collecting that data and providing it in, and then it can have these different actions. When we talk about robotics, again, we started off with the basics, but then we've expanded that out. We offered the first collaborative robotic system, which now exists in a couple of different locations. This is a system that we designed, understanding that facilities are designed for people. And what we're coming in with initially was a robotic provider. It is something that requires a large structure. It requires significant safety protocols. It requires significant implementation costs, which is fine in some of these cases. But there's also these moments where you need to be able to install a system that needs to possibly work beside people or needs to be able to easily retrofit it. And so we designed our AQCC, which is a collaborative robotic. And one of the things, as we'll show later on, is we've got a collaborative system that basically is touring the world right now. With collaborative systems, we do actually have a fully certified collaborative offering. C certified, OSHA certified, has all those various stamps. It can be installed, it can work by people, no further restrictions. The other part of this robotic space, as we look at kind of our AQC sitting in the center, we also see that there's needs for the heavier aspects of items. If we talk about what's typically referred to as bulky sortation. And in that space, we've designed what we released earlier this year is our AQC Flex. And this product is really focused on picking these larger items. So again, as we try to start to tie this back into the discussion point of what we're focused on, which is what's the future of the MRF, it's really the understanding of it in its totality. So understanding the material coming in, and then also what's the smartest way to solve the problems that we have. So making sure that those solutions are effective. In the robotic space, that includes being able to sort large, heavy objects, as well as compostable bags, which is a program we have going forward with a couple of companies right now, and we're very excited about that. And then obviously our last kind of embodiment that we've deployed for that system around integration of AI is really looking at the integration into an optical, which now gives us the ability to use a term that's quite often maybe overused, but in our case applicable, which is really data fusion. Okay, how do I tie AI machine vision intelligence with other pieces of visioning technology to really join that at its root, to be able to leverage that going forward to make smart decisions about various forms of the material as well as various chemical compositions that are there. The other real benefit of that is you're talking about an extremely high speed material. You talk a lot about robotic space and you hear this, there's this constant chatter of, okay, what's the maximum pick rate? We think about that a little differently. We want to talk about material being removed, but if you compare robotics with optics, an optical sorter is in the order of magnitude of 10 to 20,000 sorts picks per minute, if you want to qualify it in that term. So really that has a very effective space to be applied in. And because of the way that we laid out, the technology integration with the different companies, that allows that to be a very integrated product. And again, provide a lot of feedback into the main system. Again, building the case for now that I've got these individual contributing pieces, how do I bring this together in its totality and really apply it in a very actionable way? So not just a point solution of, hey, I've got a piece of equipment that can solve your specific problem, but then how do I bring that across and how do I apply that to a multitude of problems and really bring a complete integration, right? Because again, where we see the future of waste processing is in this autonomous behavior, the ability to have bidirectional communication between individual pieces of equipment, as well as a central understanding within the facility to not only bring data in, turn it into actionable information, and then be able to drive that information. So as we were going down this path of, okay, how do we get there? It became very quick to us roughly 3 years ago that we needed to be able to control or have access to the control system of the facility. That's a very unique idea, even in some of the spaces when you talk about more industrialized zones. If you talk about steel processing, metal processing, advanced or current level engineering and assembly, this is a level that we knew we needed to get to, and we needed to apply that into the waste industry because it is one of the few spaces where your inbound commodities have a huge amount of variability into what you're trying to extract. So what we're doing now is really expanding that out. So we want to understand what the inbound material is. We want to drive commercial discussions around that with our suppliers. We also want to have the intelligence and the capability and flexibility with the facilities to be able to make the appropriate decisions to create the product that we need on the back end. And then we want to be able to quantify that. We want to give ourselves a scorecard to say, how good or bad are we doing in this functionality? And that's really what drove kind of this next step evolution for us, is to how do we move that forward in a broader sense. And so what we developed was our total intelligence platform. What this is it basically becomes the central nervous system for a facility that basically now allows all of these pieces of equipment, as well as, so both our intelligent equipment, which would include our vision systems, our robotic systems, our optical system, but also includes scales, moisture meters, all of these other pieces of information that can now be funneled together and to collectively start to make some decisions and observations about what's going on in the behavior of not only the localized waste processing facility, but also look at material trends, which we can now plot over time, with also looking at maintenance and labor, as well as looking at uptime and complete efficiency of a facility, right? So as we're going through this, the real focus was to build out a central system that has that capability. I know this slide's a little bit busy, but at the same point in time, it's really meant to reflect, the totality and the depth at which we're applying technology and the depth in which we believe to be what's needed to carry us forward into the future, so that we're designing facilities that now have the ability to react and evolve as we go forward into the future and what we're looking at, right? So building on that, one of the key aspects that we're always talking about is having worldwide exposure. This is kind of a global footprint of not all NRT installations, but really just the ones we are currently looking at around Max. We're currently have, as you can tell, a large feeding base. And at each one of these locations, the information that we're gathering for machine vision is brought back into a centralized space so that we're able to then evaluate how that's relevant to what's going on in other parts of the world. For example, we look at Australian data to help us with what we're doing in the Northeast of America. We use all this information to basically build out much stronger databases and effectiveness in a multitude of different spaces, as well as be in front of changes that we see at various different geographic locations that are really driven by sociological changes that are happening. And as a waste processor, and as we try to collectively understand better how the world's evolving and what this is being used for, that becomes paramount in understanding the right way to build systems going forward so that we can then leverage that to be as effective as we possibly can and to drive the highest amount of diversion, highest amount of recovery, and the highest amount of purity, which are really kind of the main stakeholders in what we're trying to get to, right? So building on that, what we want to do now is we wanted to go forward and talk about some real world examples that we've deployed into the space and talk a little bit about some of the examples and technologies that have been put into place. This specific facility was brought online earlier this year. It's a facility that was primarily manual sorting and really came to be just looking for that total package and the ability to provide a level of integration that couldn't really be done by individual product providers. So point solutions really didn't solve the need here. And so as we looked at this, this has become one of the, if not the largest robotic fleet in the world currently, sorting waste. It's a system basically utilizing 4 optical sorters, most of those performing NIR, and then 23 robotic sorters that are sitting in place, sorting everything from aluminum PET, a large portion on producing a high quality paper product. And really the importance of this is that it demonstrates the ability to bring this all together in a very real way and facilitate all the data. So this plant, as an example, has our total intelligence platform, and it basically brings back information from all the optical sorters, all 23 robotic sorters, back to a central dashboard, back to a central HMI. But then the plant operator can look at the data, review the data, see that in real time, and then if decisions are needed around how to operate the plant, they have that ability to do so. A big step forward for us as far as the level of integration that we've provided and the number of robotic sorters in any given, in any specific location, right? Then one of the last examples that we wanted to talk about is a system we have in Norway. We've worked with this customer quite extensively. And really the focus that they were driving to was really multifolded in what they wanted to do. They obviously wanted higher throughput. They also needed to understand, the levels of purity, the level of recovery that we have within the system. And it was really paramount for them to be able to look at that data in real time while having robotic sorting systems that were present there to reduce labor as part of that going forward. In this case, this system was basically set up processing. They're roughly 20 tons per hour. They're doing a light film product, or excuse me, a light fiber product that's coming through, and really focused on purity and recovery of that material. In this case, we offer our Color Plus optical with integrated viz. We have a Spider R in this case, and then an AQC. And then if you look at that lower left-hand image, we also implemented our vision characterization, system characterization units on the back of those strings. What that does is we now have a complete visionary package on this system, and we're able to understand the performance and benefits at each one of these locations. And so what that allows us to do is not only refine the process, but then understand the data that's going out for them commercially. And that was just such a huge piece of what was present and what was going out. They've worked with us extensively, themselves and their customers, to help us collect data, to help us understand how effective our vision systems are, how effective we were doing at not only the process of recovery and purity, but then also the data systems. I'm happy to say, and we're still going through this, system's been monitored since early 19. We've continued to monitor that on a regular basis through current day. And on an average, we're approximately a 0.5 percentile to 0.1 percentile variation between what their customers are providing them for final product and what our vision system is providing them for final product. So that's a very big milestone for us and a huge milestone for them, not only from an operational standpoint, but a huge success for them around reaching their targets of being able to really drive technology forward into the waste processing space, and what we're trying to do. So as part of that, they won Norway's smartest industrial company. That was awarded to them middle of last year. And obviously we were very happy to participate in what's going on there. So again, kind of as we talk about the future of where we're going, and as we talk about automation, this is really kind of one step, the next step level in what we see offered around the world. And the fact that, not only are we talking about being intelligent and following the completeness of integration and driving industrialization, but also being able to quantify that. Again, if you think about the statement made earlier, the ability to quantify the material that's coming in, the ability to quantify the performance on the back end is incredibly important. That's how AI progressively leverages itself forward for how we'll be able to define and carry that into the next space of technology and how we'll be applying that going forward. So, I think, the final piece to this is the level of integration is just paramount. Having various pieces of information and having to bring those together, anybody that's dealt with data science and understanding how that comes into play, understands how important that is, and being able to funnel that back to a central location and not just having that data, but having the information that carries forward. That's the powerful piece of what we're doing. And that's really where the hunger point is, and pain point for matter of fact, within the industry, and how we want to drive that through and how we're implementing that. Sorry, slide deck issue. And at the end here, then I just wanted to kind of touch on one other piece. We're having, we've built a demo system, our collaborative robotics, because there's such a huge question and such a hunger for that technology. We've built a demo system of that is a full running operating system. Those who attended Waste Expo or saw all the Waste Expo publicity that we got from that, this system's making a tour really around the world. Unfortunately, it seems like the U.S., some of our locations we were planning to attend they've basically been rescheduled. However, most of the European shows, at least where we have today, are going forward. So if you're around at any of these, very happy to talk to you about our technology, both collaborative space as well as how we're driving changes through advancements in autonomous behavior and AI into the recycling space. So with that, I think I'll open it up to questions, and we'll spend the back half of the hour going through discussions and talking about what we see in the space, and I'll be happy to answer any questions that we have going forward.
Great, thanks, Thomas. Just to kick the Q&A off, pretty general question, but important. How does the design of a MRF change when you integrate all this AI and automation?
Yeah, that's an interesting point that I guess I didn't touch on as strongly as I could have. What we're seeing is that historically, a lot of MRF design is built around people. If you look at even a 5 year ago, 10 year ago system, um, those systems are designed for manual sorting. And as we start to look at robotic implementation, looking at the manual labor aspects, we really see that there's a lot of efficiencies that are being gained in a greenfield application where we're coming in and changing our design strategy around access. We're changing our design strategy around performance. We're changing our design strategy around even utilization numbers. And as we think about facilities, one of the major constraints that used to be a big driver for a lot of the industry is when you talk about lunches, when you talk about breaks, when you talk about these different pieces, that has to be calculated in the physical design. Many of the designs we're working on now, especially as we talk about autonomous, I want to be choice in how, I don't want to give too much away, but even autonomous behavior of things like container lines, where we have machine to machine, bilateral communication. Those aspects are really driving the change in how much equipment we have present in the system, and how many of those are getting rolled out into larger systems. So as we look at that, we really see that there's really almost a context shift in new designs and how that gets implemented compared to what it was years ago, as well as the ability to have the drive to have flexibility within the system, because now you have historically, and I think BHS built a reputation around building very large scale flexible systems that are able to handle large difference in material. However, as we go forward, we're now seeing that operators have this, once they have this information in their hands, they want the ability to drive the flexibility of a facility going forward. So those have really, between the characterization and the robotics systems, have really started to accelerate the evolution of even something as simple as structure design, guarding, all these other pieces.
Great, thank you. One question I feel like we have to ask, as many of us are ready to sort of get on from this, but has COVID affected the implementation of AI in recycling facilities? And I imagine that it has, but could you explain a little bit how?
Sure. Yeah, we're happy to do that. It's unfortunate. It seems to have really constrained a lot of the market space, much as it has everywhere. Look, I think in many ways the waste space is unique, and in many ways it's suffering from many of the issues that we see, almost globally. The space absolutely saw constraints around labor and is still actually suffering from that. Whether that's completely COVID related or not, that's obviously arguable, but it's a real problem that has to be addressed. So COVID definitely, exacerbated the situation there. I think from our standpoint, we were very aggressive about the way that we dealt with COVID and the implementation. And so we were able to keep people in the field. So we kept our installations going. So we kept a lot of what's going on with our customers, minimized. We did have some impacts like everybody else. But I think one of the other pieces is we've seen other areas of the waste stream itself amplified and completely shifted. If you look at the commercial streams that used to be present pre-COVID, that almost virtually dissolved post-COVID. If you look at some of the commercial, some of the markets around consumer goods, that saw a huge spike. We also saw the near instant request for, can you sort masks? Can you sort gloves? Can you sort all these different pieces? And one of the big, revolutions that we had, maybe not a revolution, but one of the big things that came forward to us, and we always knew it was the case, but it's nice to have, confirmation. Happily to say, our systems were able to, because of the way that we build neural networks and deal with categories and everything else, our systems were able to sort masks, we're able to sort gloves, we're able to sort these materials that needed to be separated out. And we didn't have any impact to robotic performance or detection performance as part of that. But we absolutely saw, the market shift, and we definitely saw the huge impact that was there. And look, our customers that had data in place, our customers that were already ahead of the curve, were the ones that responded and reacted the quickest, and were able to, minimize that impact as much as possible. I also think, look, we're in an unprecedented time where we're seeing commodity price growth that's very aggressive, and we're seeing that move around a little bit more now. But it's really a great time for recycling, and again, not that diminishes the need for this for more technology, more capability. If anything, it adds greater need to that, because now, as we start to talk about being able to characterize and define the materials that we have, we're able to drive the commodities on those. We're able to certify product. We're able to really carry that forward. Again, maximizing value in a market that seems to be very aggressive already is a great thing to be able to do, right? So those are kind of the generalized impacts that we've seen as we've gone through the system.
And another question that came in, what is the typical lead time to implement this total intelligence system into a MRF?
Yeah, so from that standpoint, it really depends on the facility. If it's a relatively smaller facility that's being built out, we have roughly a 24-week lead time on some of those larger systems. Ultimately, that's carried along with many different items that go into it. So it's a little bit of a loaded question. The important thing to remember with TIP is it's not just funneling intelligence data back, it's also funneling information from drives, information from VFDs that might be present, information from a bevy of different sensory pieces of information, because it is in its totality controlling the whole system. And so there are some limitations around the current hardware that may be present in a facility. And so that's obviously something we're happy to talk through with. But even when we talk about uptime, downtimes, maintenance regimens, all these things that go into that system, it's important to look at it maybe in its totality. So, that's one of those areas that we really welcome a conversation around as to, okay, what's it take, and really what's the customer looking to do? Because again, what we're trying to provide and what we think the industry is going is really around building something that works for your business. So many times we talk about how exciting AI is. We talk about how great new optical sorting technology is. And trust me, I love to geek out on all that stuff, and I think it's great. At the same point, if it doesn't tie back to a commercial objective, really difficult to drive that. So we really want to, as we're interfacing with our customers, we really want to understand what those are and carry that forward. And then we're able to give a much better projection on cost, time, all these other metrics around productivity.
And there's a couple questions that came in about this, but from your perspective, in countries where there's mixed waste, specifically, we got two questions and asking about India specifically. Do you think that robotic solutions have the potential to work in those areas?
Absolutely. From the standpoint, so that's a multifaceted question, right? I mean, there's many things that you want to look at in a region such as India, right? And do I think robotics can be effective? Absolutely. Do I think vision systems can be effective? Absolutely. In many ways, those locations almost benefit more from those technologies than others because of the fact, the ability to characterize the variability that you see in those facilities, right? I think it's unique in the labor structure that exists within India. And that would be an area that, from a commercial standpoint, you'd want to look at. However, I know that there's a drive in many regions where we're trying to get people away from waste, right? We don't want individuals handling that. And so the more we can drive robotic expansion, the better off we're going to be. And the fact that you need the characterization to really help. I think it can absolutely be impactful in those spaces. And I don't say that without understanding the real complication that exists. Lots of film, lots of what we would call the dirty of the dirty as far as material goes. But still, that technology can apply there. And look, that's a great region overall, and it's a great region to see that technology expand into.
And everyone wants to talk about data, what data they can get from these new technologies. Can you talk a little bit about how operators can leverage the material data that they're getting to improve the purity of the end product?
Yeah, that's a great question. Well, I think it starts with understanding the front end. It starts with understanding the material you have coming in, and then being able to take that and look at the trends and information to really be able to drive performance changes, right? So be able to have that actionable item on the back end, is paramount. To have data come through is one thing, but to really be able to drive that into information is the key. I think historically, what's been done is manual sorting on the back end. And really what that does is just give you a retrospective, hey, did I do good? Hey, did I do bad in processing that? When we talk about that conversion data to information, really our focus is around two real pieces here. One is real-time visualization of what's coming in and how it's performing, right? We're people in general, very visual in nature. And so really driving that visual recognition. The second part of that is being able to drive trending so that we can then drive, intuition and anticipation of shifts. So you want the real time to be able to react quickly, make changes, do what you need to. You also want the long-term data of a facility operating so that you understand, preemptively, because we all know there's seasonal changes in waste streams, preemptively how to move your operation around and make changes that aren't equipment related, right? How do I blend material? When should I be blending? How much should I be blending? On the back end, how much am I going to be able to extract and really be able to work with consumers on the bale side as to where the value is in that? There's kind of this point at which we want to be able to provide to a contract what we're providing, right? We don't want to put more energy into that. At the same point, we want to be able to provide a high quality product. So I think having that real time aspect and the trending is what now allows you to turn that into actionable information. There's also a huge space in development we have going on around applying AI to data, which is really a space that's been developing now since the 70s. And so we're also applying it in that space to really drive, intuitive changes. Now, the base and the framing of your question was really around, okay, I got bad material and I'm going to turn that into good material. I think it's important to remember it's not a magic wand. We can't wave, you don't wave AI or sprinkle AI over things and suddenly it becomes magically better. But what it does allow you to do is have a level of information you never had before in a time frame that you never had before, and the ability to trend that over a significant amount of time that's not grossly, the dollar per byte, if you will, is very, very inexpensive compared to what you're talking about with manual sorters. So those are really the areas where, the data that starts to be funneling in really starts to drive benefit. The second part of this whole data, we talked about the performance, right, where the points I laid out. The other part of this is around the maintenance, the operational schematics that you're using, and understanding things like power consumption, understanding things like, okay, what is the most efficient way to operate my plant? Should I be running 3 shifts? Should I actually run 2 longer shifts and work through the nuances of how that plays forward? Looking at your material quality, your times, your maintenance, everything else coming together, you can really make more of a totality decision, which really drives how you're operating the business effectively. Many times, the focus is on, okay, here's my purity, here's my recovery. Those are the numbers I'm driving to. And rightly so, you should be focused on the product. You've also got an entire business though that's sitting there. So our real focus is, how do we take TIP, take all these great exciting things AI is doing with vision and characterization, take the data, turn that into actionable information and funnel that into a working business system to allow greater decisions on things, including, purity recovery, but further than that, right? And expanding it out.
And we're getting a lot of questions asking, about any sort of material limitations when it comes to this type of technology. Obviously, there are some, but could you talk a little bit about any limitations in terms of material sorting when it comes to AI and robotics?
Sure, there's always going to be limitations. Look, at the end of the day, we're talking about a piece of equipment, right? It's got a glitz around it because it's AI based, as does everybody. There's always going to be limitations in how you apply that equipment and how you integrate that into a system. For us, what we've done is basically looked at those limitations and then tried to apply various products to solve that. One of the core aspects around AI and some of its limiters is around the ability to only see surface level information. So if you look at most of the applications of AI today, whether that be NIR or that be color, you've got the system only sees kind of the surface of the material, right? So really you're trying to understand what's present. If you talk about a large pile of material, you say, I've got a tipping floor, you're going to be able to understand the top of that, but you're not going to be able to understand the depths. We've done a lot around some of the assumptions and measuring those depths in order to kind of qualify that. But look, material presence is always going to be, presentation is always going to be a driving factor into the effectiveness of the material that's coming through. I think also when you talk about robotics, look, there are some limitations, but at the same point in time, you've got everything today in a common industrial settings where robots are sorting everything from 5mm ball bearings up to picking up automobiles and moving those around. So from the robotic standpoint, I don't see that being so much a limitation around that core technology as much as where you've seen the growth to date with the sorting technology being applied in the waste space and in some of the other kind of what I'll call tangential markets that exist around that. So again, robotics, not so much. Grasping is something that's constantly evolving. We're looking for new ways to do that. AI is really, the driven about visual presence the same way a person is. So I think those are really kind of the core limiters that are there. But when you look at those limiters versus the upside, there's a much bigger upplay to that than to work through the mechanical systems of material distribution or material sizing, which are problems that have been solved for years now, right?
And can you talk a little bit about maintenance on these systems? What that schedule looks like, what goes into that, what it would be like in a facility.
Yeah, sure. And it'll depend a lot on our products. Our collaborative product is much more gentle because of the pick rates and the collaborative nature than something that's more, for lack of a better term, more aggressive in its pick strategies around our AQCs. Generally, what's going to be the wear items will be around cups, which is what's contacting the material directly. And in the case of vacuum systems, it's going to be around any hoses as well as maintenance around, generators or collection systems. Those are all going to need, some attentive maintenance that goes into them. Robotics overall, very low maintenance items, don't need a huge amount of attention to those. And the same thing can be said for some of the mechanical systems that are out there supporting it. The vision system needs very little maintenance to that system. We utilize LED illumination, as I think most do. We also leverage that with our other product lines, opticals, characterization. So it's a common product for us. Those are really kind of the major areas. And look, I think maintenance is always a point of discussion because as we talk about robotic systems, we want to make sure we're doing the appropriate offset around manual labor, right? And I think what we're looking at is as we deploy these larger fleets, there's an efficiency and economy in motion that definitely helps in that space. But I think still one of the core areas that constantly needs and gets innovation for us is around grasping any surface that really contacts material, right?
And I think we have time for just a couple more questions, but
Yeah.
can you talk a little bit about the pre-processing steps before this material goes into the robotics and AI? There was a couple questions about, if you think that this has potential to be able to work outside of, any sort of community sorting of recyclables. Can you touch on the sort of pre-process a little bit and how that
Yeah,
impacts
absolutely.
everything?
Yeah, absolutely. So really, the pre-processing can be stated very simply, okay, especially around material characterization. If the material is singulated out, that's really the maximum pre-processing we're looking for. Now, there's still some issues if something's, blinded or covered, or, you've got to be able to see the core material, but that is it at its core is really the main limitation. So for the characterization, so in situations where we're in upstream processes where we're detecting, compressor tanks, propane tanks, doing these detections like that, really, again, simulation is what we're looking for. The system can be trained. We're able to, relatively easily move through those. When you start to talk about the robotic systems, it's really a discussion around preparation for performance. Okay, if you're expecting a robotic system to make a very large sort decision, meaning that 10 to 20,000 sorts I was talking about earlier, you're really going to be overwhelming a robotic system, right? So when you talk about pre-processing, you really got to think about processing in its totality. So really, if you're looking at removing a large number of objects, you want to do optical sorting. You're trying to do it before that. You've got density, you've got sizing separation that needs to happen. In our QC application, that's typically our general flow and our approach to materials. We've got several patented processes around how we process material. We think that's the best. When you're talking about, for example, our Flex product, there are some limitations to prep for that material around weight. But again, that's easily solved with larger robots, larger grasping systems, so on and so forth. So really the pre-processing needed for the vision system is, core singulation. You can't blind the material. And even in a situation where we describe what's typically called as occlusion, we can handle a higher occlusion rate, which is overlapping objects and some of those other nuances, but you really have to be able to see the material. So pre-processing for that is really what you need. Now, that being said, I think at this point, we've processed everything from raw coming through our system to size reduced coming through our system, and even dealing with some of the larger, pre-sorted, or what I would call is what would be typically pre-sorted material, which would be removed, tennis shoes, all these other, textiles and all these other things that come into play. Really, the systems have adapted and come a long way in their ability to handle a lot of that material. So again, pre-processing is needed, but the level at which will depend a lot on the material stream that's coming in, and applying the correct technology to that. And I think that's the critical piece that has to make sure that we're keeping an eye on, right?
Great, thank you. And I think we'll just wrap it up here with one last question. I wanted to, talk, it's a little more general and will probably be, an easier question for you, but this technology was launched 4.5 years ago. And so what is the most surprising or, integral thing that you guys have learned throughout this entire process?
Yeah, that's a great question, which I could go into the nuances of dealing with supply chain and chip shortages, or I could go into the discussion around, waste. I think one of the most impactful things that we've seen, really surprising, I'd have to say, is just how good the systems behave in many cases. I know very early on when we deployed, our first, we always define it as kind of the first 10. we were really learning. We had a really strong experience background in waste. That's in our DNA. We've done that for years. We had, a strong presence in technology and development. Bringing that, especially our first AQC into the space and understanding how good the characterization worked and how good the robotic systems behaved and how durable they were in those systems was really an eye opener for us and many of our customers. It's also been, it's very interesting for us that we have, I'll deviate a little bit from the core of the discussion, but around, the discussion of mechanical sympathy. And what's really been, I did a lot of work prior to deploying Max around just studying the people, right? Looking at the people that are doing manual sorting, looking at the people that are interacting with those and how they interact with machines and everything else that goes on there. And while some have a real infatuation with robotics and really kind of almost this reverence, which is somewhat unnerving, there's also others that have no mechanical sympathy for anything. Meaning, a robotic system has a moment where there's something gets stuck or there's a misdetection or whatever. It's really called out and there's really a strong focus on that and, really an intent to understand what's happening there. If that's a person that's standing there, there's really not a struggle. Somebody turns around and talks, lets all this material go by. Nobody really cares. So really, a core of it is just having the ability and really the opportunity, which I'm very grateful for, to be able to study how this technology has progressively grown in, and the fact that you have we have a lot of customers who are very successful deploying this technology. And those are the ones who have really just embraced it and really said, look, this is where it is. We see the value and they're seeing that return. We've had others that we needed to be more hands-on with, and they ultimately saw great success as well once they got engaged there. So I think just the social aspects of robotics and AI and how that's grown into the system, and I'm sure we're going to see more, has just been very, in many ways, it's been a little bit troubling as I share kind of more of a personal perspective. But it's also been very invigorating for me and invigorating for the team and invigorating for our company to really see the way that, not only the impact of AI and robotics and data has, on the commercial, but also the way it affects people day in, day out. A little anecdote, we had in several locations that we've implemented our technologies in, there's been individuals who are responsible for the collection of this manual data. Right? As they come back and as we deploy systems, we put Max in, we get TIP, this response of, I can really elevate what I'm doing and I can provide a huge amount of value to the company is just extremely rewarding to us. And it's been one of those things that I don't really know that I completely anticipated, because that's not something I would have been used to in maybe some of the other industries that I had participated prior. So a lot of, I guess, maybe a couple personal notes and commercial notes, but it is very exciting. It is seeing a lot of changes. We're really looking forward to kind of the next tier in automation and, what that looks like for the industry and, again, other adjacent industries as we go forward. So.
Thank you so much, Thomas. And just before we wrap up, if any of our attendees are interested in learning more or want to ask any direct questions, is there a contact that you want to give out? Who should they go to, or a website where they can, find a link?
Yeah, sure. If you look at the slide that's currently up, max-ai.com is kind of our main location for Max-related information. You can also go to bhs.com, nrtsorters.com. We have basically funnel points at all of those so that you can get in and see. And then we can get connections to all the right people. We really try to drive kind of a depth of understanding within our organization. And so if you have those questions, you can funnel those in there, and then those will come out to, whether that's a sales rep, technical resource, service resource, all of these different aspects of the business. Those can all be funneled through there, and then they'll be distributed out appropriately. So we get the right person, to really talk about the details of what the inquiry is.
Awesome. Thank you so much. And just a reminder that this will be available via recording in about 7 to 10 business days. Everyone listening, in case you missed something or want to go back and listen to a portion of this again. But I think that wraps things up for today. Thank you so much, Thomas and BHS, for presenting. It was a great afternoon. We really appreciate it.
It's great. Thank you, everyone.
Thank you.